see a diamond to a methyl to a methyl to a double bond to number 6. Straight over number 5. Straight up to number 4. And that gets a methyl up there. And now what it's going to do is it's going to go to carbon number 3. Let's color that double bond in. This is called the stereochemistry again. When there's a double bond, it puts it flat because the bond goes up and down. So now this is going to go down a carbon to an OH. To a carbon-carbon OH, actually. So go down, and then we'll run the terminal alcohol. So everything is still the same, except over here it took a cis direction on that double bond. Put your H's in. Methyls, get those out of the way. Those are easy now, right? They're on the end, nothing to it. CH3, 1, 2, 3. There's that 1, 1, 2, 1, 1, 2, 1, 2. So again, your C, H, and O going on. 6, 7, 8, 9, 10. There's still 10 carbons. There's 1 O, just like the geranium. We didn't count the H's on these. 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and that. So that makes it 18. Don't forget there's a proton inside that alcohol. So this C1010, if it's got 18 H's, it's going to be the exact same carbon. So let's do our S carbon first. It's got 1 there on the same ones, 4, 4 and 7. You got the scarlet for the methyls. So I see 3 methyls on there that, and the ones that typically the end of the chain. Our CH2s get orange H's and brown C's. So we got 3 of those. I mean, come on, kids. Is this that difficult? You don't even need the numbers. I put them in just to make sure that you count right. Remember, painting by numbers? This is coloring molecules by numbers. These get purple now, right? All right, let's see how many H's we got now. 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Inside this alcohol, so there's 18. Nerol from lemongrass has exactly the same number of atoms that the rosy smell of geraniums have. So one has a sweet rosy smell like in lemongrass, and just because of the way it cricks up on that alcohol, ethanol we would call it, the 2 going up there, gives it a different smell. Different aroma. So there's that. Nerol. Have something to do with naming after Nero, huh? OL is always the alcohol on there. So our next one, we're getting to lemongrass again. Citral. You see some other side groups. Look here, we got a aldehyde. A ketone on the end, that's an aldehyde. So I wrote octatriene al. Triene, 3 double bonds. Octa, there's 8. So the first diamond here, we're going to do our aldehyde on. And it's going to go right to a diamond. It's going to have another double bond. Before I get too far ahead of myself and lose track of the numbers, I'm going to color these in. I'm going to hope that the aldehyde is the predominant number here. So that's where we pick to start numbering from. So we'll call that 1, 2, 3. Now we got 8 to go. 1 double bond of there, so this gets a methyl on top. Make that real small because that's not pertinent. So 8 straight across. So here's number 4. Here's number 5. Here's number 6. 2, let's see here, 7. See, I'm confused, so I'm just going to draw the 8, and this double bond is going to have to get one on the inside. It won't be as colorful as the other one, but it looks like the double bond here is between the 6 and the 7. So when I look at the original, you got a carbon, second carbon in, which is this one. It's methyl, and the double bond goes this way. See, there's 2 different ways to draw your double bonds here. I like this way, but just happened to turn out that way. And the aldehyde, see, this is just straight carbons across. We have 1, 2 double bonds. So let's see what we got here. We got CHO. There's 1 O we know. There's 8, 9, 10 carbons all together. So this, again, is just like the last 2 that we did. C10, 1O. Let's see how many H's we got. This could be an isomer of these guys. So this is what our plan is now. We find the carbons that are totally saturated before we draw the H's. So I see number 3. So if somebody goes through and they start coloring these haphazardly, real fast, color them in, look how smart I am. They're not going to remember this. And this is the important part. See number 7 here. All the bonds on 7 are to carbons or electronegative atoms, in this case all carbons. This actually gets an H on it. So we got 2 that are the S hybrids. Next we go to the CH2s. These are both going to be 1s. So here's a 2. CH2. Looks like that's going to be about it, huh?